right up to your face. But I think it'll be good.
Okay, I can...
We'll adjust as needed.
Okay.
If we need to, we might give you, are you coding a lot?
No.
Okay. That might be the backup option, because I want everyone to hear you.
I mean, I will project. It shouldn't, don't worry.
Rather than me manhandling you, can we get this closer up? Is that bad for feedback?
Let's see, I've never had to deal with the second mic, so thanks for introducing another variable, Jared.
You know I like making a
I know.
If you don't cry before an event that I do, then it's not right. Yeah, you can get like above that button.
I'm gonna hit that 9% beer so hard after this.
I'll take it right after. Cool, thanks. Just want to make sure the video is good for everyone at home.
Yeah, I was just saying to Henley that if this isn't loud enough, then we can move to it.
Okay.
I mean, 3 microphones, 4 microphones, I like one in both hands, that's fine.
Should his mic be pointed up though?
Well, I'm trying to get it closer to his face.
It's always better.
Kind of a little...
Here, let me just try something really quickly. I'm trying to see how we even got this in here. Okay, give me 1 sec. I kind of want to get it through here. That's what I want to do.
Yeah, that's what I...
Sorry, I'm going to just take this out right now. How does that even happen?
I feel like maybe if you like pull it apart a little. I tried to get it through there before too, but...
That's where it should go.
Yeah.
Alright, give me 1 sec. There's any way we can... Here, I'll be right back. Let me see if I can do this. I don't know how this came out. This came loose in the first place.
Yeah, some...
Here, let me check the...
heavy mystery. Hi. Awesome. You too. How are things? Pardon?
You have a great event here tonight.
Yeah.
Are you going to do a class soon?
I did one.
We can't have you handing out flyers here. We don't do that. Yeah, we can have to hand them after here.
Is someone else with you tonight?
Pardon?
Is someone else with you tonight?
No, just here. Yeah.
Are you doing class in New York soon?
Yeah, I did one today and yesterday.
Oh, I see.
Yeah, so that's what I was here for.
How big is the class now?
I was 70.
Oh, the one I attended was 40.
Yeah, it's got a lot bigger.
Yeah, cool.
Hadley, I'm sorry to do this to you. I'm going to give you the handheld, if that's okay. Just because I want to make sure people hear you. And we just have not had very good luck with this mic in the past. And then, like 5 minutes into your talk, people are going to say they can't hear you, and then I'm going to...
Yeah, I mean, I can manage. I'm not a huge fan of handouts, but I can make it work.
Okay, thank you. Sorry about that.
At least I'm not. Yeah, it should be okay. Yeah, I already switched it on.
Too?
Yeah.
All right, guys, we're gonna get started. Find your seats. Everyone, come on back. Find your seats, please. Point out that we're in New York, we have so many healthcare, not a single finance guy. Vinny is not here. One more.
So if you like diamonds, we have a manager of data science position at the Gemological Institute of America.
All right, wonderful. And since we all know you like pizza, we want to know how much you like pizza. So if everyone could take out their smartphones, or their internet-connected laptops, or tablets, or whatever you got, and go to bit.ly/pizzapull. For those of you who don't know, and those of you who do, I'm reiterating, we've been tracking the monthly pizza here for the past 4 years. There's you'll see the top of the page is a lovely D3 chart there, generated by R charts. So all R code that generated the D3 to show this. The data gets stored in a MySQL database, and the feed is available to you in JSON if you want to do your own data manipulation. So if anyone wants that, I'll get you the data source. I said find the link. But bit.ly/pizza full, rank the pizza, excellent, good, average, poor, never again. The pizza is from Fiore's down Bleecker Street. It is based on, if anyone's ever heard of Joe and Pat's down in Staten Island, famous pizzeria from the 60s, it's almost an exact copy, even down to the oven. So everyone please vote. Next up, you probably saw on the table on the way in, we have more of those NYC Data Mafia, NYR, and IR New York t-shirts. They're for sale. Joe will happily sell you one for $20. They will go to the meetup, and actually have to pay Drew Conway and Adam Hogan, who designed them. Anyone remember Drew Conway? Yeah, of course you do. Yeah, and Adam Hogan, he was here for a while, but unfortunately went back to Chicago. He is, that's good to hear. Great. For those of you who want to attend Strata, that's coming up in just a few weeks, if you want a discount code, because Hadley told me earlier, never pay full price for anything at O'Reilly. So if you want a discount code, it's UGNYHACR20. It's a very long discount code, so you can find it on the meetup page and all of our postings, UGNYHACR20 for a discount code to O'Reilly. If people want to remember that, I will give you a little postcard. In fact, you take half, take more, and sort of throw them at people. All right, thank you. Next up, this only applies to students, so I'm sorry for all you non-students. The MBA is having a hackathon about basketball analytics. So if any students here want to participate in an MBA basketball hackathon, go to the announcement, the discussion board for the meetup group, and there's a link to it there. I think it's like mbahackathon.com, but go find the link, and you can sign up for that. It's going to be a lot of fun. We're making a big push for analytics there, so definitely go check that out. After the meetup, whenever we're done, we're going to go to Rye House. Everyone here remember Rye House? It's a little tepid. Regulars, they all know what Rye House is. For the non-regulars, we will lead you there. There's an amazing avenue for right selection, great whiskey selection. I think they have wine, but I don't really know. And they have good food. So everyone go to Rye House after this. Before I do the rest of the announcements, I want to thank Workbench for letting us pack so many people into a lovely space and not killing me. So I think Jess from Workbench, let's.
Thank you. Good evening, everyone. Welcome. My name is Jessica Lynn. I'm with Workbench. Previously been here or attended our New York Art Conference. Awesome. So maybe running around with a GoPro next to her head. Very thrilled to have you for this very special meetup tonight. Our God, not our God. So very excited to have you all with us. For those of you who are new to Workbench, we are an enterprise-focused venture fund and community, which means that we love startups that are using data and analytics to build transformative software for large Fortune 1000 companies. So if you're on the startup side, if you're on the corporate side, or you're just looking to connect with some awesome enterprise startups, we here at Workbench would love to chat. So with that, a very big thank you again, and have a great meetup.
Thank you, Jess. Everyone, round of applause for Workbench. Just a few more announcements and giveaways, and I'll let you get to Hadley. October, next month, our speaker is going to be the infamous J.D. Long, right back there. He once gave a talk at a conference all in the style of Dr. Seuss. And in his bio he sent me, James writes poorly commented inefficient code using Python, R, SQL, and expletives. So you know that it's going to be an amazing talk in October. In November, the day before the election, we will have Hillary Parker and David Robinson analyzing the text of the candidates. So D-Rob, you're here, right? D-Rob. If you guys don't know him, he's one who became famous recently for analyzing Donald Trump's tweets and finding out the angry Android ones were him, and the nicer, yeah, that's him. Okay, next up, if anyone wants our markdown cheat sheets, we got them here. So, I see a hand up. Hadley, can you deliver the first one? And I'll do the same thing. I'll split this up. Whoever wants them, Whoever doesn't, just don't leave them on the floor. Take half, please. And I'll take another half over here. And if you want one, grab it before she takes it. Cool. All right. Next up. Sorry, guys. I got to get through this stuff. I know it's taking a while, but we got to do this. We have books to give away. Anyone have a Sharpie on them, by the way? Yes. Who has a Sharpie? Throw it up here. You have one on you? Wonderful. You're going to need it. So, we're going to give away our packages. Yeah. We have 3 of them. So, first up, drawn randomly using the sample function in R. With a seed that was set 4 weeks ago, the last time I set a seed. James Beveridge. Yes, come on down. Actually, James, come on down. We're going to make this a very inefficient process. Oh, score, thank you. I think you got it covered, Thank you so much. Thank you for the effort. Everyone applause them for the pens. All right, next up, Bonnie Ray. Bonnie Ray?
James, right?
All right. Clifford Lau. Really? We have this many no-shows. Wait. Can someone check, is that really Clifford? All right, got Clifford coming right here for his copy of our packages. Got a pose with that link? Someone take a picture. Tweet it, please. Tweet it. Hashtag our stats. Over here. Oh. Wait. Hold on. Wait, that reminds me. They did want me to say hashtag our stats NYC Data Mafia. All right, come on, everyone. Hashtag is up. Then the last copy of our packages by Hadley Whitcomb. Michael Talk.
Clip. Yeah.
We're applauding for you. That means you have to be here. All right, you lost your chance. David Crawford. Oh, you're actually here, though. All right, but you won, so you're declined because you won. Yeah, you won this, didn't you? Oh. O'Reilly sent me a lot of copies. All right, Mike Lawrence. Seriously? All right, ready? Wait, that's a terrible idea. I'm not going to throw it, Jess. Am I allowed to throw things in it now? She's like mommy. Kaushik Reddy. All right. Oh, there we go. And you have won a suspiciously large amount of stuff, too. Well, luckily, he was my student, so I trust him. Hashtag our stats. All right. All right. And we have a tradition here for some reason. I don't know why. We keep giving Hadley t-shirts every time he speaks. We gave him an NYC Data Mafia t-shirt, we gave him an IR New York t-shirt, and today we are giving him an NYC Data Bikers t-shirt. You can see this is our code. It's nyc.data.bikers gets pizza plus ice cream plus bike. And the back of the biker so concerned with holding their ice cream and their pizza, they're not biking. So, Hadley, enjoy.
Thanks.
And this one I have to because my friend Kirk Metler, who doesn't seem to be here tonight, made this, and I just have to embarrass Hadley. Yep. It's still unworn, and probably will remain that way, but it's going to get framed one day. So, with that, thank you everyone very much. I hope you have a wonderful time. And I present to you, Hadley Wickham.
Thanks, Jared. So the room's a little large, so I'll kind of give you 50-50, or I could stand right in the middle where it's uncomfortable for everyone. But so today I want to talk about the Tidyverse, which is kind of an ecosystem of packages that are designed to make data science or data analysis easier. And whenever I talk about data science, I always show this diagram, because I think it's really useful to think about what are the tools you need to do data science. And to me, there really are kind of, you have to count these carefully, 7 key tools for doing data science. So first of all, you have to start by importing your data. You've got to get it out of whatever crazy format your collaborators have stored it in and into R or whatever data analysis environment you're using. Now, once you've done that, you need to, I think it's a really good idea to tidy it or store your data in a consistent format. That's important basically because it's going to save you a lot of time, because if you store things consistently, rather than having to sort of think about every time, how do I access a variable, how do I access an observation, you've got one consistent way of doing it. Then you'll often do some transformation. That's things like creating new variables that are functions of existing variables, or computing summaries where you collapse down many values to a single value. Then after that, there really are 2 main engines of data discovery: visualization and modeling. So visualization is great because it's fundamentally a human activity. A visualization can surprise you. You can see something that you did not expect. And you can also use visualizations to help you refine your questions of the data. The problem with visualizations, however, is that because they are a human activity, they don't scale very well. A human brain has to look at every visualization. So as you get more and more data or more and more variables, you can't look at every possible visualization. So to me, the complementary tool to visualization is modeling. Modeling is fundamentally a computational or mathematical or statistical tool, which once you've made your question sufficiently precise, you can answer it very efficiently. Or even if it's not very efficiently, you can just throw more and more computers at the problem. But every model, by its nature, makes assumptions. And a model cannot question those assumptions. So that means in some fundamental sense, a model can never surprise you. So models scale well, they don't surprise you. Visualizations don't scale well, but they do surprise you. So in any real analysis, you're going to do both modeling and visualization again and again and again. Now, once you've done your fantastic data analysis, which you think is just the most amazing and brilliant analysis you've ever seen, it really doesn't matter unless you can explain that analysis to someone else. You need to be able to communicate your results. And I think that's a really, really important part of data science. And again, that human part of getting the insights that you've built up through struggle and toil with the data to be able to help other people get to those insights as quickly as possible. And then I think all of this is kind of embedded inside tools of programming. You cannot do data analysis or data science unless it is on a computer, so you also need to be able to tools that kind of tie all these pieces together in a programming language. I think when we look at a diagram like this, it is very, very easy to look at those individual tools and kind of forget about those arrows. So when you look at this diagram, I think you see like this. You see all the words in bold. I'm gonna import my data, I'm gonna tidy it, I'm gonna transform, I'm gonna visualize, I'm gonna model it, I'm gonna communicate it. But I think just as important are the connections between those tools. Because if those connections are really strong and really fluid, it makes the iterative process of doing data analysis much, much, much easier. And so that's what I want to talk about tonight. I want to talk about the Tidyverse, which is a set of packages that are designed to work well together, that are designed so that you can spend your precious cognitive energy focusing on the specific challenges of your data analysis, not fighting with your tools, fighting to get the output from one function to the input of another function. And so I want to talk about today is sort of what I'm calling the Tidy Tools manifesto. So how do you design tidy tools, which I think is useful if you're developing packages, and how do you think about these tidy tools, how do you use the same ideas to make your own code, your own data analyses more effective? So I'm going to talk about, give you 3 main points for the tidy tools manifesto. So first of all, I'm going to talk about how important it is to share data structures across packages, how important it is to solve complex problems by composing simple pieces. I'm going to talk about functional programming and why you should embrace it. In other words, why for loops are bad. And then I want to talk finally again about humans. That the human is a fundamentally important part of the process and you cannot ignore it. It's not just about the computer. You have to recognize and embrace the limitations of the human. So I wanted to talk first about this idea that you want to share data structures. You don't just want to have consistent data structures within a package, but you want to have consistent data structures across the packages you use. And I think one of the really important parts of that is this idea of tidy data. And you can boil tidy data down to 2 basic principles. So first of all, you want to put each data set you have in a data frame, and then secondly, you want to make sure each variable goes in a column of that data frame. And if you follow this principle, you get what I call tidy data, or what a database expert would basically call COD's third normal form. You get data that is stored in a consistent, uniform way, which is going to make the rest of your data analysis process easier. Now, I'm going to give you guys a little challenge, which is probably going to be a little hard because these screens are small. But one of the reasons this is so important is because there's only one type of tidy data. There's basically an infinite number of shapes of messy data. And so tidying up messy data is really, really important because it makes everything else easier. So I'm going to give you this challenge. This is a data set from the World Health Organization. It is some data about cases of tuberculosis. And what I want you guys to do is take a look at it and see if you can figure out what are the variables in this data set. So I'm going to give you one little hint. That's F stands for female, U stands for unknown, and 1-5 stands for 15 to 24. So what I want you to do, take a minute, crane your neck, strain your eyes, see if you can figure out what are the variables in this data set. Okay, so if you are in like the first 3 rows, does anyone want to volunteer what one of the variables in this data set is?
The actual thing being counted doesn't actually explicitly say anywhere what it is.
Okay, so you have gone immediately to the most difficult variable in this data set to spot, and that is the number of cases. So these counts in here, in this table, these are the count the number of cases of TB, which is not explicitly labeled anywhere. What are some of the easier variables to spot here? I think there's one that's particularly easy. Year is really easy, right? Because that's already a column. If we've got a column next to it called ISO2, you might be able to guess from the context. This is the World Health Organization, so there's going to be data about every country. ISO2 is the ISO 2-letter abbreviation. AD stands for Andorra. So we've got 3 variables, right? 2 of them, year and country, are in columns. We've got a third variable that's sort of all inside this matrix. And then we've got 2 other variables that are spread across these columns, that occur in the column names. So we've got the gender and the age. So we've got 5 variables here, and they are stored in 3 different ways. And you can imagine that inconsistency is going to make it difficult to work with this data, because you have to, if you think about how would you get all the observations corresponding to 1995, you'd have to use one tool to do that. What if you wanted to find all of the years and countries where there were 5 males who had TB. You'd have to use a completely different approach. So the goal of tidy data, the goal of tidying your data is to put it in this consistent form. And one of the packages of the Tidyverse that helps you do that is the Tidyr package, which recently I discovered. I didn't do this deliberately, but Tidyr is actually an anagram of dirty, which I think is really, really clever, but I only did it by accident. So here's a pipeline. We'll talk a little bit about the pipeline very shortly, this idea, but I'm going to read in that data. I'm going to use some tools. I'm going to gather together all of the columns that are not variables. Then I'm going to make, and that's going to make 2 new columns called demo, short for demographic, and the number of cases. I'm going to split that apart, do a little bit more tidying up, a little more cleaning, and I'm going to get this data set. So this is a tidy data set because each variable is a column in this data frame. And that makes life easier because now everything's stored in a consistent way. You can use one tool to work with it regardless of which variable it is. Now, so if you do have data of you have variables and observations, it's a really good idea to make sure you store it as tidy data. Now, that's not true of every possible data set. There are lots of other things like matrices and XML and vectors and strings and so on. But even if that's not possible, if you can't use a tidy data frame, I think it's a really good idea to at least be consistent. Now, there's one other challenge. So what happens if you have lots of different types of objects? And I think an interesting place where this comes up is cross-validation. So in cross-validation, for example, you're going to take your data set, you're going to split into training data and test data. From that training data set, you're going to fit a model to it. You're going to combine that model with the test data to generate predictions. And then you're going to combine the predictions with the original values to calculate some kind of measure of the quality of that model, like the root mean squared error. So when you do this, when you do cross-validation, you're not going to do it once, right? You're going to do it multiple times. So how do you keep all this information together in a way that's easy to use? And in R, there's a really neat technique for that, and that's to use this idea of a list column. So a data frame is a list of vectors, and a list is a vector, so that means one of your columns of a data frame can be a list. So here I have a data frame that stores a whole 90 cross-validation samples. I've got one column for the training data, one column for the test data, one column for the model, one column for the root mean squared, and so on. So even when you have more complicated objects like models or test or training data sets, you can still store these together in a single data frame, which makes your life much easier because now you no longer have to worry about when you subset or when you sort one of the vectors to sort every other vector in exactly the same way. Now, using list columns with data frames is a little bit challenging, and that's because, I mean, data frames, don't get me wrong, data frames are absolutely fantastic, but they have a couple of surprising behaviors. So I'm going to give you guys a little challenge. Again, I want you to read this code, which hopefully everyone can actually read at this time, and I want you to evaluate this code in your head. So no cheating, you're not allowed to use R. I want you to run this code in your head and predict what the output is going to be. So talk it over with your neighbors, see if you all agree. I'm going to give you a minute starting now to evaluate that code. So if you're doing this in R, it'll be much faster, but your brain's a little slower. Okay, time's up. So there are 2 surprising things about this bit of code. So first of all, does anyone want to take a stab at what this code's gonna return? Yep.
Numeric value 0.
It's going to return the numeric value 0. Okay. What else?
It's going to return a vector.
It's going to return a vector. What? Can you tell me anything about that vector? An empty vector. Okay. Any other suggestions? Yeah? It's going to turn a factor. That's an interesting statement. So let's actually run that code. It returns a factor that levels A. So there's two surprising behaviors of data frames. So first of all, remember data frames always like to convert your strings to factors. And the other thing is data frames, when you index a data frame, it uses partial matching. So if you give it a unique prefix of an existing variable name, it'll return that. So I don't want to kind of like bag on base R because it's not like, first of all, it's not very useful, but secondly, these decisions were made for a good reason. And I think when you're understanding the behavior of base R and the quirks of base R, there are two tensions that it's really useful to bear in mind. So the first tension is a tension between interactive analysis and programming. So R is not just a programming language. R is also an interactive environment for data analysis. And I think when people, if you're very experienced with another programming language and you come to use R, people often think, oh my God, R is crazy, and the people who have written it must be insane. That's not entirely true. It's because R is not just a programming language, it's also an interactive environment. And there's things you want in a programming language that are great for programming languages that are not so great for interactive analysis. So when you think about this tension, base R is fairly far on the sort of interactive tool. It's designed to help you understand your data interactively. It's not the goal of base R is not to be the sort of most amazing programming language that's strict and robust that you've ever used. The other tension I think it's really useful to bear in mind is the sort of tension between conservatism and utopianism. So a conservative basically wants things to stay the same. And in base R, that means that you can write base R code. If you wrote base R code like 10 years ago, the chances are today it's still going to run. So that conservatism is a really strong value, right? Because it means code keeps on working. The downside of that is that it means if you made a mistake 10 years ago, it's very, very difficult to create that mistake. So kind of the other side of the spectrum is utopianism. So if you're a utopian, you're like, well, this one little thing isn't very good. Burn it all down and start from scratch. So base R is very much on the kind of conservative side of things. So yes, they made mistakes, and R core absolutely understands that these are mistakes, but it's very, very difficult to change them without breaking the sort of fundamental value of conservatism. Now, I personally, obviously, are far, far more on the utopian side, and I'm very happy to burn things down if they don't work quite right. Now, that obviously has some advantages. It means you're not locked into mistakes that you made a long time ago, but it does mean that things are constantly changing. Maybe code that you wrote a year ago no longer works. Or maybe you learned reshape, and then you're like, oh my God, now there's reshape 2, I've got to learn. Oh no, now reshape 2 is gone, I've got to learn Tidyr, right? That's the trade-off. So one of these things that I've been working on a little bit lately is this idea of a tibble. And tibbles are basically data frames, except they are lazy and they are surly. So what do I mean by that? So if you create a tibble exactly the same as the data frame we just created, and you try and access it, well, first of all, they're lazy. They never turn strings into factors, no matter how much you might want them to. And if you subset them to try and extract a single column, they always... And one of the reasons I bring up tibbles now is tibbles also make it a little bit easier to work with list columns. So if you try and put a list in an ordinary R data frame, it thinks that you're giving it a list of columns, basically. It sort of spreads them out wide, and so you'll get an error when you try and add a fairly simple list. You can work around that by using this I function, which tells R not to do that, but to put them in the rows instead of the columns. But when you print it out, it's a little hard to see what's going on. Well, it's a little hard here to see what's going on with tibbles anyway, but tibbles do work a little bit better with lists. And the print method for tibbles also tells you the type of each column, which is really, really useful, particularly for verifying that your strings haven't been turned into factors. Okay, so that's the principle of sharing data structures. The idea is the more people, the more packages share the same underlying data structures, the easier it is for you to combine tools across packages. I think it's really two really powerful ideas of this idea of tidy data, where you put your variables in the columns, and also this idea of tibbles, which is sort of a modern reimagining of data frames, which keep the things that have stood the test of time and get rid of the things that are now just more frustrating, that are more pain than they're worth. So that's the first principle, share data structures. The second principle is compose simple pieces. So the goal, when you're solving a complex problem, a really powerful way of doing that, a really general and useful way of doing that, is by taking lots of little simple pieces and combining them together. And we see this lots and lots in real life, right? The reason why container ships are so successful is they kind of you can put whatever you like in here, but it's wrapped up in this sort of simple, consistent interface that can be combined together and shipped all over the world. Lego is another great example. Each Lego block, you can look at a Lego block and you can understand it easily, right? It's very, very simple. You can see how different Lego blocks connect, but your creativity is almost unlimited. You can still create very, very complex things using these simple pieces. And the thing that I think plays this role really well in R is this pipe. So how many of you have seen the pipe before or used it? Okay, cool. So if you haven't seen it, I'm going to tell you a little story about a little bunny named Fufu. So our little bunny Fufu hopped through the forest, scooped up a field mouse, and bopped it on the head. And here I've written that sequence of actions as if it's a sequence of function calls. And I've nested them, as you often do when you have lots of function calls. And this is a little tricky to read because you've got to read it from inside out, and the arguments of the function end up spread quite far apart. So what the pipe allows you to do, it's a syntactic transformation. From R's perspective, the code is basically the same, but it allows you to kind of flip it so you can write these functions almost as if they're imperative sequence of statements. Little bunny Fufu hops through the forest, scoops up a field mouse, and then bops it on the head. And this is important, this idea, this pipe potentially provides sort of a unifying way of composing simple pieces across packages. And I want to kind of illustrate that by showing what happens when that doesn't work, or when you try and combine dplyr and ggplot2. So here I've got some flights data, I group it by date, I summarize it to count the number of flights on each date, and now I want to visualize it. I can pipe, oh, and now I have to use plus. So that's a bummer because it can't join these simple pieces across packages. I've got to switch mindset halfway through. And annoyingly, even ggplot2 isn't even internally consistent. So I'm creating a plot, I am adding some points, I'm adding a smooth, and now I want to save it. That does not work. Instead, you have to write something like this, which is frankly quite hideous. Now, as an interesting sort of historical note, ggplot1 actually was completely internally consistent. So ggplot1 was built around this idea of function composition. And recently I kind of bought, originally it was called ggplot, I call it ggplot1 just to make it more clear now. I actually bought ggplot1 kind of back to life, so there's not really any reason to use it except for kind of historical interest. But the thing that's really neat is this is how I envisioned you would write ggplot code, ggplot1 code. And the reason that I have ggplot2 is we switched to plus, because I pretty quickly realized this is an unappealing code to write and to read. But interestingly, it works really, really well with the pipe. So if I discovered the pipe back then, there never would have been a ggplot2. There just would have been ggplot1 with the pipe. And just to kind of prove that it still works, here's the plot, which looks surprisingly similar to what you'd see in ggplot2. So I wanted to show another little example. This one is from Bob Reuters, just showing the sort of the benefits of the ability to chain these pieces together across multiple packages. This is a little example of scraping some, unfortunately, mass shooting data. So it uses 5 packages, Arvis, Purr, Redar, dplyr, and lubridate. You start by reading the HTML, then we extract all of the nodes which have a link that starts with docs.goo. So this is the first part of the URL that will go to a Google Doc. Then it extracts the href, the link to those Google Docs. Then it uses map and read.csv together to read each of the CSVs for those URLs and combine them together in a single data frame. Then we create Well, we modify the date variable to be a proper date variable in R using the MDY function from Lubridate, which passes dates in the form month, day, year, and then finally we assign that to a variable called shooting. Now here you'll notice I've used the rightwards assignment arrow, which I still have exceedingly mixed feelings about, but it does feel very, very natural in the middle of the end of the pipe to assign the result of that pipe to an object. Okay, so that was the idea of combining simple pieces. So each of these pieces, each of these functions is simple, you can understand it in isolation, and the way you solve complex problems is by combining these simple pieces together. And I think one of the things that's appealing about that sort of strategy is you can take like one little step and see if you've moved in the right direction. If you haven't moved in the right direction, you take a step back, but you haven't lost much, you haven't moved very far. So you can take a little step, check each time, and eventually you'll get to where you're going. I think that's a much more effective way than kind of taking like a very long wander, and then you realize, oh, I'm in the wrong place, I'm going to have to back up like 15 minutes or an hour's work. So the next strategy I want to talk about is this idea of embracing functional programming, and in general, like embracing the things that make functional programming languages so cool. Or sort of another framing of this is, why are for loops bad? And if you've used R for a while, I'm sure someone has told you that for loops are bad, and maybe someone has told you that you're a bad person for using for loops. And this is absolutely not the case. Like whatever code solves your problem is good code. But I think if you just stick with for loops, you lose out on some really important and really powerful techniques that will help you become a better programmer and help you solve new problems with ease. And I'm going to illustrate these ideas with some cupcake recipes. So this is a recipe for vanilla cupcakes. So how many of you made cupcakes from scratch before? I continue to be surprised by the number of people who come to my talks who have made cupcakes. So if you've never made cupcakes before, this recipe is great because it's very, very, very explicit. You know, it tells you to put the flour, sugar, baking powder, salt in a freestanding electric mixer with a paddle attachment and beat it on slow speed. Or my favorite instruction is turn up the mix until, no, sorry, that's not my favorite instruction. My favorite instruction is continue mixing for a couple more minutes until the batter is smooth, but do not overmix. I think you can probably take that as a given that you should never overmix anything, like you shouldn't overcook anything. Anyway, so this recipe is great if you have never made cupcakes before, or indeed, really, if you've never done any baking before. But the downside of this recipe is because it's so verbose, it's hard to see how does this recipe differ from other cupcake recipes. And so here is a recipe for chocolate cupcakes. So what's the difference between vanilla cupcakes and chocolate cupcakes? Well, the recipe is like 99% the same, right? There's only one little difference, which is kind of hard to spot, especially since you can't read the text. But if I pause, the only difference between vanilla cupcakes and chocolate cupcakes is that chocolate cupcakes have cocoa in them. Right? This is not like this is not the baking research discovery of the century. But it's certainly hard to see that when you look at these two recipes. So what I'm going to do is refactor these recipes to try and make that more clear, what the difference between these recipes is. And the first thing I'm going to do, there's sort of an unfortunate backstory to this particular recipe, is that one of my best friends in New Zealand bought this recipe cookbook, the Hummingbird Bakery cookbook, and she made some cupcakes from it, and she said they were fantastic. And then I bought the cookbook here in America, and I tried making the cupcakes, and they turned out terrible. And that's not because I'm a bad cook. It's because I unfortunately bought the American version of the cookbook, which uses these ridiculous measurements like a scant 3/4 cup of sugar. So the first thing I'm going to do is transform this into realistic measurements using weights. So that's like a fun aside. I don't think it has any direct impact on functional programming. But the next thing I'm going to do is I'm going to assume some domain knowledge. I'm going to assume that you've done a little bit of baking before. Maybe you haven't made cupcakes, but you've baked something like this before. And when I do that, I can now simplify the instructions for this recipe I can make them much, much smaller. And then the other thing I can do is I can start to use variables. Rather than listing the things, I'm going to say beat together all the dry ingredients, mix together the wet ingredients. And the thing that's neat about this is now that I've reduced that recipe to the point, I can put 2 recipes on a single page. And this is powerful because now you can see exactly how vanilla cupcakes and chocolate cupcakes differ. It's not just that we add cocoa. You can see there's 120 grams of flour here, 100 grams of flour, and 20 grams of cocoa. So what we've done is replace flour with cocoa. So this is valuable to know now, right? Because now you have this slider. You can control the chocolatiness of a cupcake from not at all to extremely. And that's a valuable insight, right? Because now you're moving from just creating a specific recipe to creating an entire class of recipes. So what on earth does that have to do with functional programming? Well, let's go back to a couple of for loops. So I want you to look at these for loops. Again, if you can see them, try and figure out what do these for loops do, what is the same, and what is different. So take 30 seconds or so, see if you can puzzle out these for loops. So what do both of these for loops do? What do they have in common? Well, if you read them carefully, you'll see they both basically iterate over the columns of this empty cars data frame. What's different about them? Well, the first for loop computes the mean, and the second for loop computes the median. So when you use for loops, what for loops tend to do is emphasize the objects that are being transformed. But really, in this case, those objects are the same. What you want to focus on is what's the actions, what transformation is occurring. And that is what functional programming is really great at. So if you, instead of using your own for loop, basically what you're going to do is you're going to use a function that has written that for loop for you. So all mapdevil does, really, is it just has that for loop inside the function and it does it for you. So now it is much, much easier to see what's going on because we've removed all of that boilerplate that you need every single time you write a for loop. So this is kind of the simplest, the lowest level use of functional programming. I think this is still really powerful. It doesn't allow you to do anything that you couldn't do before, but it allows you to do it with greater ease and with a lesser chance of creating bugs because you're relying on someone else's code. Oh, so Purr is this is my package for doing functional programming. It stands for, I kind of forget what it stands for. It stands for make your pure functions purr in R. It has 5 letters because dplyr, ggviz, read R, and something else also has 5 letters, so it lines up nicely at the start of your package, at the start of your code. And it is also a nod to the powerful R cat ladies. Hashtag, who you do not want to anger. Okay, so that's like the simplest level of a for loop. You can, the simplest application of functional programming, you can kind of move up the tower of abstraction and do more and more powerful things. This, I think, is quite a cool idea. Here I'm doing a little simulation. I want to generate a uniform distribution with a minimum of 1 and a maximum, well, minimum 1, -1, it should be a maximum of 1 there. I want to generate a random normal with a standard deviation of 5. I want a Poisson with a lambda of 10, and so on. And I can store this in a data frame. And I think this is a really powerful idea. Thinking about functions and their parameters as data is a really, really interesting idea. But then what I can do is I can use mutate. I'm going to add a new column, the results of my simulation using the invoke function from Purr. I call each of these functions with the parameters specified as well as this constant parameter for all of them that I want 10 random samples. Or here's another really cool idea. So here I'm going to generate some parameterized R Markdown reports. I want to do one report for each unique value of the class variable in the MPG dataset. I want to save it to a file called fuel-economy, then the name of the class, .html, and then the parameters to that report is going to be my class equals the class name, and then I can use this pwalk function, which is basically going to call R markdown render once for each of these class variables. It's going to supply the parameters, and it's going to supply the output file name, so you're going to easily generate multiple reports, one for each value of this variable. So that's the idea. That's sort of the idea of embracing functional programming. And even at the simplest level, it allows you to replace for loops with things that are easier to write and easier to read and highlight the actions rather than the objects. And then you can build up from that to progressively more and more complicated things, which I think are still really useful and really powerful in a data analysis. I wanted to finish off by talking about this idea of writing for humans, which honestly I don't entirely know what that means, except that it's really important. And I really like this quote from Hal Albelson, who's a very famous and well-respected computer scientist, that really the goal of a program, the goal of code, is to communicate with other humans. It's really only incidental that the computer can go away and run this. And I think thinking about code as communication is really, really important, because I mean, every project you work on is always fundamentally collaborative, because you're always working on it with future you. And if you don't want future you to be cussing out past you, it is a really good idea to make sure that your code not only works, but it conveys what it does. It communicates its purpose. So I've got kind of like 3 little things that I think are somehow related to this idea that you're not just writing for computers, you're writing for humans. So the first is some of these package names. So forcats is a very new package that I wrote like 2 weeks ago. It is a package for categorical variables. That is also an anagram of factors. And again, it is a nod to the cat ladies community. So I'm pretty sure my package naming skills have now peaked with that package. But we've also got Magritte, inspired by the famous Magritte painting. This is not a pipe. We've got tibbles, we've got lubricate. Like, I want, when you're doing data analysis in R, I want it to be fun. It should be fun. What you're doing is fundamentally interesting and fun, and I want the names of the packages to have a little bit of humor in them. And some of the names of the functions, recently Tibble just got a tribble function, so you can talk about the trouble with tribbles. I think another thing that is fun is the idea of making sure, like, I want you to like identify a little bit as like, you're someone who not only uses R, but you're proud of it, like you're excited about it. You think, you know, Broom is cool. Broom's a neat package by David Robertson that takes your models and turns them into tidy data frames. You're excited about ggplot2, dplyr, Purr, and you're not afraid to show it by putting a sticker on your laptop. And you'll see my laptop is getting kind of a little excessively overfull. So I'm going to have to stop writing packages once the stickers can no longer fit on my laptop. So that's sort of 2 parts of it. There's like humor, this sort of human that you're not doing this alone. You're part of a clan. And then finally, this sort of idea that when you name functions, and these are the 5 most important functions from dplyr, you know, English is not precise enough to convey all the information, to convey everything you want with a function name, but at least think about function names that kind of evoke the general idea that filter is for picking variables, mutate changes your data by adding a new variable. Arrange changes the order. Select allows you to pick variables. Like thinking carefully about how you name your variables, how you name your arguments, I think is challenging but extremely worthwhile. So I shared with you 4 principles. So you want to share data structures across packages. The tidy tibble is a particularly powerful idea because most of the time in statistics and data analysis, we are working with variables and cases or observations. A really good strategy for solving complex problems is by composing simple pieces. A great way to do that in R is the simple pieces are simple functions that you can easily understand in isolation, and you compose them together using the pipe. And the great thing about the pipe is that it works across packages, and the other thing that's great about the pipe, which I didn't mention, is that if you don't like the pipe, you don't have to use it. It's not like the plus in ggplot2, which you're forced to using regardless of whether you think it's a good idea or not. You can still do all the other ways of composing functions you're already used to, or you can use the pipe. Embracing functional programming is important, not because for loops are bad, but because there are tools that allow you to work with more ease, that allow you to produce code that's easier to write and then later on easier to understand. And this fourth bullet point, which I still don't exactly know what it means, but this idea that it's not just about the computer, right? It is about other people. And thinking about those other people is important. So my kind of goal is to create a pit of success. So a pit of success is very different to a pinnacle of success, right? Because a pinnacle of success is hard work. You have to climb that mountain to get to the top. The goal of a pit of success is you just kind of like fall in by accident. And I absolutely admit that we're still a long way away from R being this pit of success. But the idea of the Tidyverse, the packages of the Tidyverse that share these common conventions, make it more likely that you are going to fall into this pit and be successful. So along those lines, one package that I've released very, very recently, like 2 days ago, I think, is this new package called Tidyverse. So if you install Tidyverse, this will install all of the packages in the Tidyverse, so you've got them all on your computer. And then you can also, if you load the Tidyverse package, that loads for you the 6 packages that I think are the most important that you're likely to use for every data analysis: ggplot2, tibble, Tidyr, dplyr, and Purr. It also gives you like a convenient summary of some of the dubious decisions that I've made to override base functions, which I will not go into now, but at least it shows you clearly where the potential problems might be. So I just wanted to finish off with this diagram again. This, to me, are the current set of packages in the Tidyverse. I want to emphasize one of the things that people used to call this collection of packages that work together nicely, which I barely only manage to say is the Hadleyverse, which I really dislike because when I say it, it makes me sound like an egotistical maniac. But the thing that's really important is that the Tidyverse is not about me. None of these packages were created in isolation. Many of these, even now, like Lubridators, I barely have anything to do with it these days. Many of these packages, stringr builds on top of the fantastic stringI package. HTTR builds on top of curl. There are other packages that I have had nothing to do with. David Robinson's Broom package, the DBI package for talking to databases. This is not just about me. This is a collection of packages that share a common philosophy, a uniform way of thinking about data that when you use them together makes your life easier. Thank you. So I'm tempted to just drop the mic and walk out because I actually have a mic. But I think we have time for some questions. Go.
Repeat the question. So do you plan on making any major changes to ggplot2?
So the question is, do I plan on making any major changes to ggplot2? In general, I answer, I have decided that it's a terrible idea for me to make promises about anything such as like the infamous promise that 2016 was going to be the year of ggviz, which it is not. It is unlikely that there are going to be major changes to ggplot2 that change the way it works. I do have a fantastic intern who's working on ggplot2 this summer, who's working along some of the themes that are in the last release of making ggplot2 more extensible so that other people can build in the bits that are missing rather than me. So I wanted to highlight along those lines one really fantastic website, which is the ggplot2 extensions website. Which lists a whole bunch of these these new packages like ggiraffe and the unfortunately this is ggiraf and this is ggraph, which these are really cool packages. They extend ggplot2 to draw graphs. We've got other add-on packages that add a whole bunch more themes. If you've ever dyed to make your ggplot2 look like a starter package or a Excel package. You can do that with GG themes. There's some cool ones. GG repel is really neat. It adds text labels that are automatically pushed away from each other. GG alt, GG force, and GG alt, which add a whole bunch of other little useful tools. So the goal, the thing I really want to embrace with ggplot2 going forward, there will be some sort of little minor changes here and there, but to make it as easy as possible for other people to extend it in a way that works for them. I have to say I have been like incredibly tempted to make a ggplot3, which would be exactly the same as ggplot2, but it would work with the pipe. But I've resisted that temptation so far.
Along those lines, why not just overload the pipe operator to be plus ggplot option?
So the question was, why couldn't I just make basically the pipe and plus somehow work together? But unfortunately, it's basically impossible for that to work. It would be exceedingly difficult and fragile.
Is it still one line of code if it's got 10 pipes in it?
Yeah. So the question was, is it still one line of code if it's got 10 pipes in it? I don't know. There's something about that kind of like semantic chunking of information that people use. There are a lot of people who use really, really big, complicated pipes, which I think like once you're above like 10 lines within a pipe, it's starting to get too complicated. You should save it to an intermediate variable. And the reason you should do that is because you can name that intermediate variable, and that name conveys information about what you're trying to do. But that said, I think that structure is very natural. It's like a paragraph, and you can read each line like a sentence. So I don't know. I think it's easier to read than one big, like, giant blob of code with no white space. But you still want to use, not everything needs to be in one pipe.
Can you talk more about the path to your vision? Like, I've been using a lot of these graphic tools for the last 15, 20 years, and I've kind of learned the Tidyverse tools piecemeal as different. Basically, what happens is there's some great package to solve some problem I need to get that package, and I see that it's using one of your tools, and therefore I learn these paradigms. But it seems like there's very piecemeal spreading out through the whole universe of packages, and this is sort of a nice compact nexus of things. But how do you see it spreading out to the larger universe?
Yeah, so to summarize, the question was basically, I think, how did I get to the Tidyverse and where is the Tidyverse going? And I think sort of the way that I got here, I think is interesting. Like, to me, there's something kind of powerful about like names and spaces, which is sort of very abstract. But this, like, I think one of the reasons that I never really thought so much about how these packages fit together was people called it the Hadleyverse, and I just could not stand that name. So I like avoided thinking about it. But as soon as I called it the Tidyverse and sort of started to think, well, it's not just individual packages, but it's how all these things fit together. It's a sort of shape, how these things fit together. Then it sort of started to become like more obvious to me, like what are the pieces and how do they fit together? And for example, that was one of the things that led to the development of the 4cats package, because it's sort of obvious. Oh, you've got lubridate for dates, you've got strings for strings, string out for strings. What do you have for factors? So sort of, and then the name that helped me think about it, and then the space, like the right. It's not just stuff that lives in one package. It's this encompassing concept, and then having the idea of this Tidyverse package, which is where like meta Tidyverse stuff can live. So for example, and that package also contains a vignette, which basically contains this sort of manifesto in text form. The thing I think, like going forward, I mean, the hope is now that I'm starting to make these principles explicit, and this is, basically my first or second attempt at doing that, and I think there'll be quite a lot of iteration before it's like polished. But the idea is, again, like making it, because it's the Tidyverse, it's not the Hadleyverse, like everyone's invited. You can make a package that fits in nicely with the Tidyverse because there's now these well elucidated set of principles that you should follow. So hopefully this will sort of get bigger over time.
Following up on that, is there a way to extend these principles to Shiny?
Yeah, so the question sort of about Shiny, and I think that really comes back to this very first diagram. And the thing I really have not talked about tonight is that communicate bit. In some sense, I think that we're like, our studio is doing really nice things. Obviously, I'm a little biased because they pay my salary, but I wouldn't have joined the company if I didn't think they were doing good stuff. Like communicate to me, like I think the two tools to me that I use all the time to communicate are Markdown for producing static reports and Shiny for creating interactive web apps. Now, how these sort of ideas map to R Markdown and Shiny, they don't seem to translate immediately to me. I talk a lot with Joe, the creator of Shiny, a lot about these ideas. And he sort of has the, if anything, like the Shiny belongs to like the monad verse, which monad's kind of this fairly sophisticated functional programming idea that there's a million different tutorials written about monads, and it's impossible to understand monads. But as soon as you do understand monads, you start seeing like monads everywhere. And you think everyone should know about the power of monads. So I don't know, like I think like equally like the Tidyverse isn't the entire universe of data manipulation. There's something they can't quite articulate yet where it belongs, but it's to do with that, like the process of doing data science. And then I think the process of communicating it, there's some overlap between these universes, but it's a little bit different, I think. So the question was basically about sort of performance and consistency, and I'm going to put this slide up because by and large, I mean, my goal is to make it easier to express these ideas. I am not as interested in making it computationally efficient. That said, like as my team at RStudio grows, I'm going to have the opportunity to hire people who do care about performance and who can work on that. The other thing that I think is really important is typified by this Sparkly R package that, it's just called spark.rstudio. So Sparkly R, it's a package for connecting to Spark, obviously. But it uses the same ideas as dplyr. And one of the things that's really neat about dplyr is that it abstracts away the description of these operations from the actual implementation. So that means you can work with a data frame in memory with dplyr in exactly the same way you can work with a massive data frame that's stored in Spark. And I think that's really important, that you somehow you don't want to have these very expensive cognitive switching between different frameworks. And R is such a great language for designing like these little domain-specific languages that then can translate it to efficient code in other ways. So I guess my answer is kind of twofold. Like first of all, I'm not personally that interested in performance, but I know people do care about it. So as my team grows, there will be more people who are interested in performance. And then that said, like it's not, like R doesn't have to do everything, but R should be able to talk to everything, and it should be able to talk to these other tools in a way that's very, very natural. And I think the Sparkly R package is a really great example of that, because you can take everything you know about working with in-memory data frames and start applying that to very large out-of-memory data frames. Obviously, you're going to have to learn some new stuff as well, but at least there's not this massive, you don't have to suddenly stop using R and start using Python or Scala or Java or something.
Where do you think our base still adds value given Tidyverse?
I mean, there's still like so much. There's still a lot of things that you cannot do with the Tidyverse. I think there's lots of, so the question was about the value of base R. I don't know, I think base R is it's this like really strong, stable, solid foundation that the Tidyverse can grow out of. And the Tidyverse is like much more like waving around in the winds of fashion, I guess. And sort of slowly over time, parts of the Tidyverse kind of harden up as I figure out like what works really well. So to me, like base R is this really, really strong foundation. And it also makes the Tidyverse possible because the Tidyverse doesn't have to solve every single possible problem because you can still use base R, you can still use all of the thousands of other packages. It is this sort of ultimate shared data structure that everyone like uses. Yeah, so I'm going to paraphrase that question into a question that I've thought a little bit about and struggled with. And that is like this, it's still like when I do a data analysis, there's still like, and admittedly I don't do that much data analysis, but I still do data analyses. There's sort of like, it's surprising, there's still like a lot of duplication, right? You sort of try these different things, you want to like vary them a little bit. Maybe you kind of want to systematically vary them, maybe you just want to explore like one avenue that looks particularly promising. And then like how can you like kind of reuse that, both like within analysis, across your own analyses, and then across like other people's analyses. Like there's sort of, I think there's some, like the idea of, I think the idea of a function for as a way of like wrapping up certain behavior, like what is kind of the equivalent of a function that allows you to encapsulate some common pattern of data analysis? And I really don't know what the answer is. The thing it makes me think of a little bit is another thing that we've been working on a little bit lately at our studio. I'm just going to pull up our studio really quickly. And I think this one's okay. Let's make that text slightly larger for you. And that's the idea of like this sort of notebook interface. So in the development version of our studio, just going to click the buttons, we have this kind of notebook interface. And basically, this is sort of not, like there's multiple different concepts of notebooks, and this is really focusing on like how can you use an R Markdown document like a notebook. And what that means is like, well, instead of putting the printed output on the console and the plots in a plot pane, well, you get everything in the notebook in line. And there's some quite cool stuff. I don't know if I can find I'll just make a little toy example here. Just because I think this is really cool. Like if you have multiple chunks, multiple things you have got a plot and a data set, you get this pretty cool little gallery widget, and you can, and instead of just printing a data frame like a typewriter, you can print it like a human being. So there's something like somehow like this, like how to use like notebook type interfaces. And I think the thing that's really interesting to me about this and why this relates to your original question is there's something about the chunk that seems like the chunk is kind of the unit of composition of a data analysis in a similar way to the function being a unit of composition in programming. And I don't really know what the answer is, but that's sort of like what I'm thinking. Like it seems like we're missing something. There's something interesting with the way that chunks in a notebook compare to functions and programming. How can we kind of bring that together, make stuff easy to share? I don't know the answer, but something I'm really interested in.
So for folks that are regularly in the business of building interactive web visualizations that be integrated into the pipe, using trees and stuff like that, what are your thoughts on the best way to make that workflow work with this, and how might that interchange with tools like Tidyverse and Shiny and development?
So the other question is basically again about communication, and particularly I think if you're doing a lot of web communication on the web and you have a skills team who know just R or Python but also know JavaScript, like how do you kind of get the rest of the process to flow into that? And there's definitely this, and there's also this sort of difference between like, there's different types of communication. Like often a data scientist will do an analysis and will communicate it to like 2 other people. And in that case, the goal is just getting that speed of iteration as absolutely as quick as possible. In other cases, the data scientist might be communicating to like 10,000 people. Also the extreme of that are things like 538 and the Opshot are communicating with hundreds of thousands of people. And I think that does fundamentally change things because it changes like the relative how much effort are you willing to put into this communication piece. And I think visualization is really important there, but I just don't like know enough about that space really. That's not really the space that I work in to give really good advice. But again, just it's like thinking about these arrows is so important, like thinking about that process explicitly. And how you still do that rapid iteration for exploration and then slowly kind of like calcify it for whether it's production or large scale communication. I think those are really interesting problems. I don't know of good solutions. David.
On your last slide, you had 3 question marks in the model.
So that's this box here. Yeah, I'm not going to say anything about that really, except I think that there's still, like modeling in R is definitely one of its strengths, but a lot of the modeling functions were developed in sort of fundamentally a different era of computing. And so one thing, for example, is like when you fit a model with LM, that object contains a complete copy of the data, which is just kind of now like mind-blowing, but at the time was like really a fantastic idea and really useful. And so I think it's sort of time to start rethinking like how modeling in R should work. And that couples into like all of these other changes that your data, you want to be able to work with the key thing with working with big data is you don't want to move the data around. You want to send the computation to the data. So if your data is in Spark and you want to fit a linear model to it, you don't want to bring the data into R and fit a linear model. You want to send that parameterization of the linear model to Spark and have it fit there. And you want to be able to do that exactly. You want to be able to fit a linear model to a data set in the same way, regardless of whether that data set lives in Spark or it lives in memory. And I don't know what the answers are, but again, those are the sort of questions that I'm thinking about. How can you make it easy to express modeling in a sort of back-end agnostic way like you can in dplyr?
I also work base R, and then I learn your packages, and I use your packages, and I go back to base R for the modeling. And sometimes you're in a situation where other packages, base R doesn't understand some of your classes, and then you, for like 2 hours, don't know what's going on. And oh, it's atomic, and doesn't understand atomic. Any advice on either how to prevent those situations, or maybe make base R accept certain classes?
Yeah, that's a good question. And this actually like the introduction of like the way that tibbles work, the way that when you subset them to get a single column, you only use a single bracket, so you always get a data frame back, actually posed some sort of interesting, like it broke packages that were not in any way related, that you could not, by looking at the intersection of tibble dependencies and these other package dependencies, figure out that there might be a possibility of breakage. So I don't know. I think some of it is like making sure you give feedback to me about where things break. I mean, maybe I won't care and I'll tell you it's someone else's responsibility, but sometimes I need to hear the same thing multiple times before I realize it's a problem. The forecats package is another really great example of that, because I think I was basically in denial about the utility of factors for like 5 years. And then when I finally broke down and realized that they were useful, I discovered that they are actually really useful, but they're just missing a few key tools. So I think like some of it is definitely like tibble, like some of these packages in the Tidyverse are like deliberately aggressive. Like they're aggressive and I do these things because I know they are aggressive and I know they will break things, but sometimes the only way to figure out like what's wrong is to kind of break things deliberately and get lots of people doing it and see what breaks and then maybe back off a little bit. So that's definitely something like feeding back to me, like, and to the other people who work on these packages, like, hey, this is breaking, and we need to think about, like, is that good or bad? Should we fix that, or should someone else fix that? Otherwise, I don't know. I think like debugging is hard, and it is particularly frustrating. You know, again, it's this this trade-off between being conservative and being utopian, and some of that is just, I think you just kind of have to live with a little bit of pain in the short-term pain in the service of long-term success. And I'm kind of, on your behalf, willing to cause you a lot of pain if I think it's better for you in the long run. And maybe I'm wrong, but sometimes you just have to break stuff in order to make it better.
I think this briefly came up at the art conference too, but is anyone on your team working on package discovery and sort of like a lot of these episodes of like I didn't even know the package existed, even though it was small, like repacking them as part of using. I was wondering if you have any updates on it.
So the question was about package discovery. Like, this is my attempt at package discovery, at least putting all the packages I think are really important on a single slide. That's obviously only like a drop in the bucket, right? I think that is a real problem for the R community. Like, how do you, and it's not only for the people using the packages, but also people writing packages. Like there's, you know, like 6 different logging packages and 15 different packages for doing density estimation, and how do you pick which one? And how do you help people work together rather than everyone doing their own little different thing? And I have to say, it's sort of, when you look at, it's sort of interesting to me, like when I look at like the Python community versus the R community, in some ways it's much, there's some parts of the Python community that are great, like everyone's sort of standardized on scikit-learn. You've got this one central thing that all behaves the same way. But then when you look at like package installation in Python, like because everyone who uses, or most people using Python are fundamentally programmers, they install a package and they're like, oh, this package installation process sucks. I'm going to create my own package manager. And then you end up with a sort of proliferation of all these other tools. So I don't know, I think it's a really hard problem. Part of it is simply like you can't force, like if 3-4 people want to write a package that helps you do logging, then you can't like force them all to work together and create one package. And some of that is like just, you know, human politics. And some of it is that people are often solving genuinely but subtly different problems, and rather than like forcing them all to sort of shoehorn into one structure that doesn't fit everyone very well, or you have to create some very, very generic structure that is infinitely flexible and suits every need, but then no one understands how it works. I don't know, it's a hard problem. I think definitely on sort of the user-facing side, thinking about how we can make it easier to find packages, one of the things I am particularly interested in that aspect is like, how do you, at least when you start learning R, like what packages should you learn? What packages are likely to make you most successful? And you know, again, that's the sort of the goal of this R for Data Science book, is to like lay that out. Like I don't guarantee that, I'm not trying to say that this is the best approach ever, but this is a set of packages that work well together, and if you use them, you are likely to be successful. And that's kind of at least my kind of line in the sand. And then I think over time there needs to be like broader efforts. Like not everything is going to be in here. There's like too many domain-specific things. I don't know. It's a hard problem, and I don't know anyone. I don't know any good solutions. So I think the question, again, I'm going to kind of reframe the question. Is it sort of a worry about, like, do you end up with a sort of very monoclonal or mono kind of cultural environment where everyone is using the same tools, and then you have sort of this high risk that maybe there's a really productive area that everyone is missing because their tools are so constrained. I basically don't really worry about that, just because the R community is so diverse. The Tidyverse is really just a little part of that. Lots of people are doing other stuff, working on all sorts of other directions. And the Tidyverse is not like this walled garden. You can still use it along with everything else that you can do in R. Maybe there's a little bit of friction when you kind of break outside the Tidyverse, but I don't think it's too awful. I mean, generally, there's this, I don't know, sometimes kind of almost machismo, like, this should be really hard to do so that, like, dumbasses can't do it. Like, we want to protect this. Like, we don't want stupid people doing statistics because they'll screw it up. And I wrote this paper, which I really like the metaphor about this, which is like statisticians particularly, I think every discipline does this to some extent, but statisticians have this kind of sort of abstinence-based approach to statistics, right? You should never do statistics unless you're in a committed long-term relationship with a statistician. But the problem is, like, everyone sees like their friends fooling around with statistics and they're having like a great time and nothing goes wrong, and so they just do it anyway. So, like, you know, abstinence-based education doesn't really work. So I'm all for, like, so I'm sort of more in favor of, like, how do you, like, practice safe stats and at least, like, explicitly teach, like, these are the pitfalls and what do you need to watch out for. But you can do it yourself. You can do really good stuff. You don't have to be a trained statistician to pick up these tools and do cool stuff.
Just to follow up with a question about package discovery, because I thought about the same question when I want to do something, and it seems like I spend about a few hours just auditioning different packages and figuring out, like, this one can do this thing that I need, but can't do that other thing. Have you thought about maybe using the power of our studio, which has captured a large part of the audience, to have some kind of meta statistics about what packages people are using, what packages are dependent on other packages, to sort of say, okay, there's some kind of score that says CD plot 2 is being used by 60% of, our studio users versus this other package.
So this, again, this sort of question follows up about package discovery, and could we at our studio use what we know? I mean, part of the problem is we don't actually know anything about how people use R, because we're very careful to not know that, because we don't want to be in the business of, like, snooping in on what R code you run. That would be like a fundamental kind of breach of your privacy. So I'm going to answer your question with another website. This is the website for the Infrastructure Steering Committee of the R Consortium. We have grants available to work on projects that broadly benefit the R community, and package development is clearly something that package discovery is something that would clearly benefit the R community. So if you're hearing these questions and thinking, oh my God, I know how to solve this problem and it's super easy, then you should totally apply for an ISC grant. They'll be closing again, we need to update the website, but about January 10th. And we have funding available up to about 50K, I think, for bigger projects. And we have lots of smaller grants available on the order of like 5 or 10K. So I think I'll take one last question before I die. And JD looks so excited to ask me a question. I have to let him.
Have you ever considered doing a Q&A on Quora?
I think possibly Quora may have inserted a paid shill into the audience. I am, in fact, doing a Q&A on Quora, where you can ask me anything, and maybe I'll answer it or not. I'm already like, I'm so tempted to answer this question. Just no. I think that's a little glib. There's some really interesting questions in here. Do you remember how many votes the mother-in-law one had?
Well, I was going to ask income, but I didn't think that was fair.
The mother-in-law one is gone. Someone was asking me a question like, what do you do if your mother-in-law invades your kitchen? I'm like, so there's some quirky questions. Oh, the income one. Was it in? They seem to be like weeding out. There's some kind of wacky ones that seem to like come up and then disappear again. So if you do have other questions, this would be a great place to answer them. You can ask them for like the next week, basically. If you get enough people to vote it up and I think it's interesting, I will answer it, and probably I don't really care about how many votes it gets, but if it's interesting, I will try and answer it. But some of these questions are pretty, oh my God, like what was Leo Bryman trying to convey in his research paper? Don't ask me. How do I make a database importing multiple CSV files in R, like C Stack Overflow? Anyway, I'm only like poking fun at these questions. I won't really be mean when I answer them seriously. But if you do have other questions, that's a great place to answer them. Thanks for reminding me. So thank you all for coming.
One more round of applause for Hadley. So still some things to wrap up. Remember, go to the bar, everyone wants to come. Someone online requested that he couldn't hear people announcing jobs. So, it was you in person. So if you announce a job, post it on our discussion board or post it in the comments section of the meetup. Let everyone see you have a job available. It's free, we don't charge anything like Monster, so post away, it's actually quality jobs. Thank you again to Workbench, and everyone have a great time, and again, thank you to Hadley.